Right, okay, Year 11, and welcome to the walking, talking mock of the questions that you should have done yesterday. Please do not start this lesson if you have not completed the questions to the best of your ability. Otherwise it is pointless, because this is about how to answer exam questions. So hopefully we have attempted the questions from yesterday, and I'm going to go through and talk you through how to answer the different kinds of questions so that it doesn't take up too much time. I will be rushing through the simpler questions and focusing on command words that are a little bit trickier. So we're going to start with question number 1, and don't worry if you haven't got this printed in front of you. Following it on the screen is absolutely fine. So question number 1. A student investigated the effects of the size of marble chips on the rate of reaction between marble chips and hydrochloric acid. So they use the following method. I'm not going to go through that, but it tells you the method. They're giving you specific masses and volumes of things that they have used. We've got a picture down here that is showing how it ended up. And the first question is a how science works question, which is asking you to identify what the independent variable is and what a control variable is. Variables are anything that are going to have an effect. Please remember that in our independent variable is the one that we change. So there is only one thing that we specifically change in investigation. That is our independent variable. The dependent is what we measure. Control variables are things that we need to keep the same so they do not have an effect on the independent. So from the list, I've got some options. We need to draw one line from each variable to the example of it. So what is it that they are changing? Well, it says they're looking at the reaction, the effects of size of marble chips. So they are going to be changing the size of the marble chips. The dependent variable, I know it's not this question, but the dependent variable is measuring the mass, the change in mass over time. A control variable, well, that information is given in the method, so you need to look at something that they have kept the same every time. So they've added 10 grams of marble chips in the flask, so the mass is staying the same, but that is not one of the options. Add 50 centimeters cubed of hydrochloric acid, so they are keeping the same volume of hydrochloric acid. Is that one of the options? It is. So that is our control variable. Okay, and that's worth 2 marks. So even if you remembered just one type of variable, always have a go, and if you can't remember for the other one, it's just drawing a line. So please make sure, if anything, you have at least drawn a line to something that you think it could be. Okay, so the next question is now tying in with a chapter on chemical reactions. So the equation for the reaction is CaCO3S, 2HClAq makes CaCl2AQ, H2OL, and CO2G. Now these we should be familiar with. These are called state symbols. So if it's got brackets S, that means it is a solid. If it's L, it means it is a liquid, but that has to be a pure liquid. G is a gas, and AQ is a solution. So if it's dissolved in water, then it's going to be AQ. Okay, so we have got some solid calcium carbonate reacting with hydrochloric acid that's in water to make calcium chloride that's in the water. Water, that's pure, so that is a liquid, and carbon dioxide gas. So the question has nothing to do with those state symbols. It says name the 3 products. So hopefully we know that these are the reactants, these are the products. So it's asking you to name these different products. Okay, and we should be putting it in word form. So this one is calcium. Remember, you'll have a periodic table, so if you're unsure, have a look. Calcium, and there's Cl2, so that is calcium chloride, not chlorine. When it's joined to something, it turns to an ide. H2O, hopefully we know, is water. And CO2, hopefully we know, is carbon dioxide. Okay, so that was worth 2 marks. So if you get all 3 of them, then that is going to be worth the 2 marks. If you get 2 correct, it's 1 mark. If you get 1 or none, then that will be 0 marks. Okay, next question. Another student suggests putting some cotton wool in the top of the flask. Suggests why this improves the investigation. So why will putting some wool in here make the investigation better? Okay, now it's only worth 1 mark, so don't think that it's going to be a very complicated answer. You don't have to explain anything, so you don't need to go into too much, give too much information. And it says here, suggest. Now if you see suggest, okay, it means it comes up a lot in biology. It means there's something that you haven't covered, but you've got to use what you do know to have a good stab at it. So most of the time, it's what we would call common sense. Okay, so why do we think adding wool into the top would improve it? Kind of in common sense. So it means it's going to be something to do with the mass. So it means you're not losing any of the liquid or the acid. You could say that only the gas is allowed to leave, anything like that. Okay, so if I was writing this, suggest why this improves. So it stops acid, I'd probably put, if it was me, leaving, or coming out of the conical flask, or bubbling out of the conical flask, anything like that. Okay, part D. The reaction produces 1.6 grams of gas in 30 seconds. Calculate the mean rate of the reaction in the first 30 seconds. Now again, this question is worth 1 mark. So it is not going to be overcomplicated. It has given you the equation, so you don't get a mark for that. So we just need to put the numbers into the equation. Okay. Now, mass of product produced in grams. Hopefully you realise that G is grams, so it's going to be 1.6, and then that's over or divided by the time, which is 30. So in your calculator, you will need to have 1.6 divided by 30, and that gives you 0.0. Oh, do that again. 1.6 divided by 30 gives you 0.053333. So we can just say 0.05 will get you a mark by doing the 2 significant figures. So I'm just going to say 0.053. Okay, and even if you haven't written it down here, you would still get the mark, but I'm going to put it in there because that's where I want you to put the answer. Now, some of you might automatically, because you're good human beings, have put the units. It's grams, it's in seconds, so it's G/S. But the next question actually asks you to tick the box for which is the correct unit. So it's grams per second. Remember, if it is a rate, it's always going to be per time, okay, or per second. So none of these other ones give you per second. Okay, so it's going to be G/S. There are 2 units you need to know: grams per second and centimeters cubed per second if it's a gas. Right, next question then. So F, the table below shows the students' results. Plot the data from the table above on figure 2 and draw a line of best fit. Now please make sure, there's so many people that just leave graph questions, but it's actually easy marks. This is worth 3 marks. You're going to get a mark for drawing the line of best fit, and remember that can be either a straight line or a curve in science. And you're going to get 2 marks for getting these in the right place. So look at your scales. Okay, this is the first thing you need to do when drawing your graph. So here it goes from 0 to 10. So that means 10 little squares is worth 10. So each little square will be 1. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's important to remember for later on. This one is a different scale. So here it's got a half, or 0.5, and there's 10 little squares. So that means every 2 little squares is 0.01. Sorry, I did that a bit too high, so that's 0.02, that's 0.03, and that's 0.04. Okay, so annotate your graph, put that on your graph if that helps. You will not lose marks for doing that. So I then just have to take the results from here and plot them onto my graph. And it is not a case of just going, oh, it's about here. You need to try and be as accurate as possible. So the first one is 10, 0.8. So I go along 10, and then I need to go up 0.8. So that's 0.5, 0.6, 0.7, 0.8, and I put a cross, and the center of the cross is the point. I do not put hearts, I do not put dots, it is a cross, and in the middle of the cross is where the point needs to be. Okay, I realize as well that I have not put the first one, which is 0, 0. Be careful with that, it's very easy to do, as I have demonstrated. 20 should go up to 0.6. So 0.5, 0.6. Next one is 1.6. So that's 1.5. So that is 1.6. Next one is 1.8. So 1.5, 6, 7, 8. 50 is 2. 60 is 2. Okay, and hopefully you already can see there is a anomalous result there. There is a result that does not fit the pattern. Okay, and hopefully we can realize that is that one. So when we draw a line of best fit, if there is one that is far off, and they will make it very, very obvious that this is very far off, then ignore it. Okay, you can circle it if you want to, but do not include it in your line. Now, rates of reaction graphs, most of the time you will see them as a curve. Okay, so you can see there I just put my wrist down there, use that as a pivot, and I just did a single line. I do not want to see this. They will not give you the mark for that. If you're trying to kind of like shade it as a curve, they will not give you that. It needs to be a single pencil line. Okay, make it very, very clear. It needs to go through most of the crosses, and this will be a curve, not a straight line. Please make sure you take a pencil and a ruler to your exam. Right, and the last bit is a long question, this one. So the last part is G, and it's showing a large marble chip and 8 small marble chips. So this is going to be to do with surface area. The large marble chip has the same total volume, so that's what's inside the mass, as the 8 small marble chips, but has a different surface area. Why do the 8 small marble chips react faster than the large marble chip. And we've got multiple choice, and it's worth 1 mark, so you know you're going to have to tick 1 box, but it also tells you need to tick 1 box. So you need to read through. If you know one to be definitely not the right answer, just put a cross next to it. Okay, if you're unsure, put a question mark. If you know that that is the answer, tick it, but make sure you go through all of them before you tick one of these boxes. So the 8 small marble chips have a larger surface area, so less frequent collisions. So less frequent, no. We know that the bigger the surface area, the more frequent the collisions, so it's not that one. The 8 marble chips have a larger surface area. Small marble chips have a larger surface area, so more frequent conditions. Yeah, that sounds about right. Smaller something is, the larger the surface area. And we know that rates of reaction increase when there's more collisions. But let's keep going. The 8 small marble chips have a smaller surface area. That is not correct, because if you break something down, it will have a larger surface area. The 8 small marble chips have a smaller surface area, so again, that is incorrect. So our answer is the second box down. The smaller chips have got a larger surface area, so there are more frequent collisions. Okay, see how many you got out of 11 on that. Take a breather and we'll come back for question 2. Okay, let's move on to question 2 then. So question 2, a student investigated the rate of reaction of magnesium with dilute hydrochloric acid. This is the method they use. So add 50 centimeters cubed of acid to the conical flask, 0.2 grams of magnesium ribbon, attach a gas syringe to the conical flask and record the volume of gas every 10 seconds. And they've given us a graph to show that reaction. And the first question, A, calculate the mean rate of reaction for the first 10 seconds. Okay, now if it's asking you just to work out the mean rate, that's the nice easy one. That's where you just find the information and put it into the equation. If it had said calculate the rate of reaction at 10 seconds, that's when you would need to draw your tangent. You can work out it's only going to be worth 2 marks. So that means there's 2 things you have to do. 1, find the information. 2, do the calculation. So there's not going to be a tangent involved in this. Okay, so we need to go to 10 seconds. So we go along to 10 seconds. And then we go up, and I would suggest drawing this on your graph in an exam. And then we want to go across. And I am being as precise as possible. That is between the boxes. So I actually make it, if each one of these is worth 2, so that is 18, 17, 16. So I actually make it 17 on the side. I imagine a lot of you have gone for 16, but actually it is halfway up. So we do need to use those boxes. Now if you use 16 you would still get the mark. Okay, so do make sure that you have a go on this one. 16 would be fine. They also give it to you if you put 18 as well. So 17 is the volume of gas, so it's 17 centimeters cubed, and that is over 10 seconds. So 17 divided by 10, pop it into a calculator, or you might realise you just moved the decimal point. So that is 1.7 centimetres cubed per second. Centimetres cubed per second. Okay, so 1.7 centimetres cubed per second. Now the next question is similar to the last one, where they want us to put the unit in it still. So what is the unit? We've already put it on, is centimetres cubed per second. That is a correct unit, but the y-axis was the volume of gas, not the mass. And because it's rate, it's never divided by centimetres cubed or grams. It's always divided by time, divided by seconds. Okay, so next question, give two conclusions. So what can you see is happening? That is what a conclusion is. With the reaction between 90 and 120 seconds, use the graph. So here is 90. Here is 120 seconds. Okay, so we've got to give two conclusions for it. Now, one would be nice and easy, because I imagine most of you will go straight to it's plateaued, so the reaction is finished. If you ever see on a graph where it levels off, where it plateaus, that means the reaction is done. It is not producing any more gas over time. So the tricky bit is then to think of another conclusion. So what does it mean with the reaction actually finishing? What can we tell from the graph? Now, we know that time's still going up, but the amount of gas, the volume of gas, is not. So our second conclusion that we can give is that no more gas is being produced. Now it says here use the graph above, so that normally means there's going to be clues in there. So what does that line mean? Now other conclusions you can give on this that the mark scheme allows, as you could say the rate of reaction is 0. You can say that one of the reactants has been used up. You can say instead of reaction is finished, you can just say no reaction instead. Okay, these are the ones that I would have come up with, but there are other possibilities. First one was pretty straightforward. The second one, you do have to use your brains a little bit more and look at what the graph is showing. Use those axes. Right, the student repeated the method using magnesium powder instead of magnesium ribbon. All other variables are kept the same. What is the independent variable in this investigation? So they were using ribbon, now they're using powder. So hopefully we realise the difference between those two is the amount of surface area. So the surface area of the magnesium is the independent variable. Because remember, the independent variable is the one that you're changing. Dependent is what you're measuring. Control variables are everything else that needs to be kept the same. Okay, E, hopefully we came to the live lesson on Monday. So E, sketch a line on the graph above to show the expected results for the experiment using magnesium powder, which was very similar to the one that I made up, which came from some previous questions. So it is a very common question. So this is with the ribbon. What would it look like if we were using powder instead? Which result for using magnesium powder. So it's going to have more surface area. So the reaction is going to be faster. So we need to start our line off steeper. Okay, now it doesn't matter if you've gone that way, as long as it's here, somewhere around here, you're going to get the first mark. Okay, it's worth 2 marks, just so said in the lesson. 2 marks, normally these are worth. That will be your first mark. Okay, if you've drawn a line that's steeper than the other one. Now what's also important is that we plateau at the same place. Okay, so we need to have our line going all the way to the end in line with that. Okay, because that means that everything's used up. Okay, it can't keep going on and on and on and on and on. There is only a certain amount of magnesium and a certain amount of hydrochloric acid. So having a steeper line is worth 1 mark. Plateauing it at the same point is the second mark. So well done if you manage to get both of those. Okay, we're going to come back in a second with question 3. Right, so let's have a look at question 3. We've got another question about a practical investigation and measuring the volume of a product. So question 3, a student investigated the effect of different catalysts on the decomposition of hydrogen peroxide. So that's what we used when we did the video lesson. We've got the hydrogen peroxide and our trusty gas syringe. Oxygen is produced. Table 1 shows the observations of the students. So you've got the 4 different catalysts and you've got the observations. So the manganese dioxide, lots of gas, and hydrogen peroxide bubbles up into the gas syringe. Potato, steady bubbles of gas. Copper oxide, a few bubbles of gas. Sodium chloride, very few bubbles of gas. Which is the most useful catalyst? Explain your answer. And it's worth 2 marks. So you're going to get 1 mark for identifying, and you're going to get 1 mark for saying why it is the best. And obviously we're going to have to use the information from the table. Now, if you wrote manganese dioxide, the maximum number of marks you can get on this question is 1. So if you were in manganese dioxide, I fully understand it's producing the most amount of gas, which is why you might have put it down. You can only get a maximum of 1. You would get 1 mark for that manganese dioxide. The answer that they're looking for is actually potato. Now the clue is in the observations, because it says in the manganese dioxide that it bubbles up and the manganese dioxide goes up into the gas syringe, whereas the potato produces a steady bubbles of gas. So in terms of use in industry, the potato would be the best, and so if you put potato you get 1 mark. And then if you've gone on to explain that, so if you said it's more manageable, or if you've said it's safer, or more effective, any of those would be the 2nd mark. So I probably would have put potato as it produces a steady amount. Okay, which is what it says in the observation. Okay, so fully understand if you wrote manganese dioxide, you do still get 1 mark, but they're looking for potato because if we're actually using it, we don't want it going crazy. Right, so next up is B, and we've got a picture of our gas syringe during the investigation, and it says, what is the volume of gas? Now, I've seen this a few times, this type of question. Sometimes it's on a measuring cylinder. If it's a measuring cylinder, then you need to do it from the bottom of the meniscus. Okay, so it bubbles up like that. You need to measure it from the bottom. Okay, gas syringe a little bit easier. You're going to be measuring it from here. Okay, so we need to work out the scale. That's basically where you're getting your mark from. So if that's 50, that's 100. That must be 60, 70, 80 and 90. So it's between 70 and 80, which will be 75. So well done if you got that. They are testing you there for precision. So use the scale. Right, C. For one of the catalysts, the student measures the volume of gas given off every 20 seconds for 2 minutes. The volume of gas was 0 at the start of the experiment. It gives you some measurements. So it's asking you to complete the table. So you need to know, or you need to use your knowledge of how you can construct a table. In the 2nd column, or if there's more, all of these columns, that's what you're measuring. Okay, now in the 1st column it would be your independent variable, which in this case is actually time, because you're doing it at specific times. So we put time here, and we must include the unit. So I'm going to put an S in brackets. If you write seconds, that's absolutely fine. This bit, this is what you're measuring. It's the volume of gas. Use the terms, use the words in the sentences. Do not worry if you run out of room. Volume of gas. Please include, though, your units. Okay. Now, marks. That's 2 marks already. You get 1 mark if you've written time and volume. If you put volume of gas, great, but they're looking for the word volume. So if you've got time and volume, 1 mark. If you've got seconds or S and centimeters cubed, then that is the second mark. So 1 mark for the title, second mark for the unit. So we then need to fill in our table, and this is where we're going to get our second 2 marks, because it's worth 4 marks, second 2 marks. Now it's very important, it says the volume of gas was 0 at the start. So at 0 seconds, there is 0 volume of gas. Okay. Then it goes up every 20 seconds, so we should have 20, 40, 60, 80, 100 and 120. And then popping the numbers in, 23, 42, 59, 72, 80 and 88. If you've got all of those numbers, including the 00, that is 2 marks. If you forgot the 00, but the rest are correct, then that'll be 1 mark. Okay, next one, D, suggest why the readings might be lower than expected. Now your command word here is suggest, so it is not something that you specifically know. You've just got to think about it and make a logical kind of conclusion. So it gives you a few different answers that you could give. I would probably say that some of the gas escaped. So if you said anything about the gas escaping, so if you said that in the tube that gas escaped or something like that, that is a mark. They've also given a mark if you said there's a leak. If you said that it was too slow to put the bung on or the lid on, any of those would be worth a mark. If you put systematic error, then that would also be correct. So the last part for question 3, the student did the experiment with 4 different catalysts. Give 2 variables the student should keep constant. So this is testing you on your knowledge of variables, so control variables, okay, things that we have to keep the same every single time. So go back to your picture and have a look and have a think about what would have to be the same. So we're only changing the type of catalyst, everything else has to stay the same. Please do not talk about equipment. Do not say use the same gas syringe, because every gas syringe does the same thing. It's got the same scale, so it doesn't matter. So we need to talk about things on here. Now, I would suggest, and we look at the 2 reactants. So we've got hydrogen peroxide and the catalyst. Now we're changing the type of catalyst, but something that we should keep the same is the mass of catalyst. Please do not use the word amount. You must have mass, volume, concentration, things like that. You could also say the concentration of hydrogen peroxide. I probably would have gone for the volume of hydrogen peroxide. That is also correct. You can say the temperature, because temperature affects it, so you'd probably do it room temperature. You could say the surface area of the catalyst, so if it's been ground up or not. So all of those would be great answers. So think about things that affect the rate of a reaction, and that's what we need to keep the same. Okay, so total up out of 10 marks, and if there is anything that you're unsure about on those, then obviously please make a note of it for revision. Right, so moving on to question number 4 now, and it is another rate of reaction investigation. Very, very common for these types of questions because there is a lot of practical involved in it. It's a good way that they can test your how science works. Okay, so do make sure you pay attention to the information they give you. So a student investigated the effects of temperature on the rate of reaction. So I think this is the one that Miss Slade would have done with you. It's very common. We tend to do it every year. You've got the cross, the sodium thiosulfate. You add hydrochloric acid to it, or a dilute acid to it, and it goes cloudy, and you time how long it takes for the cross to disappear. And it gives you a method underneath it. Okay, now this is familiar, but it might give you one that's completely different. So don't be frightened if they give you something that's unfamiliar. What is important is going to be the method and any other information that they give you. Okay, it's just about application, applying your knowledge. So then we have what looks like a very scary symbol equation, and you don't need to know this symbol equation. What is important for the first question are these state symbols. Okay, so first of all, we need to know the 4 state symbols. 3 of them are the states of matter. So if it's a solid, it's an S. If it's a gas, it's a G. If it's a liquid, but it has to be pure, so nothing dissolved in it, then is a L for liquid, and AQ means it's dissolved in something. So in this case, it's dissolved in this water. So the first question says, which product is a gas? So you need to have a look at these state symbols, and hopefully we realize that that is the only products come out of a reaction, the only product that is a gas. So you can put SO2, or you can write sulfur dioxide. Okay, so that's 1 mark. So that's testing your knowledge of state symbols. So next question, B, figure 2 shows the results of this experiment at 5 different temperatures. The circled result point is anomalous. That means it doesn't, we need to know this, doesn't fit the pattern. So if it asks you what is an anomaly or an anomalous result, it's one where it doesn't fit the pattern. So part 1, draw a line of best fit. Please remember, I feel like I say this so many times, in science it can be a straight line or it can be a curve. Okay, it's not just because it says a line of best fit, it does not mean it is a straight line. So draw a line of best fit on figure 2 to show how the reaction time varied with reaction temperature. So here are our results. We ignore any anomalies. So this circled one, we're just going to pretend it is not there. And it is not going to be a straight line. This looks like a curve. So you're going to start on the either the first one or the last one, and then freehand. Remember what I said last time, I've kind of a pivot on my palm. So go through as many of the crosses as you can. You end up with a curve that looks like that. Okay, so that is worth 1 mark. So just look at the crosses. They will make it pretty straightforward. So if there are crosses all in a nice straight line, that's when we grab our ruler and we draw a line for that. But these go like this, so it's going to be a curve. 9 times out of 10, a rate of reaction graph will be a curve. Okay, part 2. Give a possible reason for the anomalous result at 40 degrees Celsius. So what could have gone wrong in our experiment that would cause this dodgy result? Okay, think about doing practicals. What might you not have gotten quite right? So one for me, a logical one, it wasn't at 40 degrees Celsius. So you could say that it was hotter, too hot, or too cold. You could say about, so that's worth 1 mark. You could say for a mark, say that they missed the point that the cross disappeared. Or you could say that they added a larger volume of acid, or a smaller volume of acid, or a larger, what was the one they were working on? A larger volume of the sodium thiosulfate, anything like that that would have an effect on the reaction. Okay, so we're going to move on to part 3 now, and this one is our rate of reaction equation. So the reaction at 20 degrees Celsius produced 0.32 grams of sulfur in 64 seconds. Calculate the rate of reaction at 20 degrees Celsius using the equation. You're not even having to use this graph. It is giving you the information that you need. It's also given you the equation. So the mass of sulfur is 0.32. It's in 64 seconds, so divide that by 64. Please put your workings out. Just going to grab my calculator. So 0.32 divided by 64 is 0.005. 0.005. Okay, and that's actually worth 2 marks. That's quite a generous one. So they would give you a mark if you've got the working out, even if the answer is wrong. If you have got the answer 0.005, then you would automatically get the 2 marks. But please always put your working out just in case. Okay. Right, so next question. Give 2 reasons why the rate of reaction increases as the temperature increases. So I went on a lot about this. We must make sure that we remember these 2. It's very common, the temperature one, because there's 2 things instead of just 1. So 2 boxes worth 2 marks. So you're obviously going to get a mark for each correct answer. So we should know that if you increase the temperature, you are giving the particles more energy, so they move faster. The next one says the particles collide less often. Is that going to make it faster? No, it is not. So put a little cross next to it. All the particles have the same energy. Well, no, they can have different amounts of energy. The particles collide with more energy. That definitely could be 1. So I'm going to put a question mark there. The number of particles increases. No, the number of particles will always remain the same. So these 2 are going to be 2 of the reasons. So they're moving faster, they collide with more energy. Right, last question for question 4. Use the correct answer from the box to complete the sentence. The minimum amount of energy particles must have to react is called the, hopefully we know this from the amount of times it came up on quiz, so it is the activation energy. To activate something means to start it. Okay, so you're starting the reaction is the activation energy, and that's worth 1 mark. So that whole question has a total of 8 marks. So tot up how many you've got out of 8, and maybe make a note of any bits that you need to go back and revise. Right, so now we move on to question number 5, and this one is looking at reversible reactions, which was the live lesson on Tuesday. So the diagram shows how anhydrous copper sulfate can be used to test for water. Remember, anhydrous means no water. Okay, the water is being removed. Hydrated is where, like, you put water in. So hydrated means there's water added. So we've got some water in a pipette, and we've got some anhydrous copper sulfate, and it's given us the equation, and it's also balanced it, and it's also told us the colours, which is great. So A, what colour change will you see when the water is added to the copper sulfate? So it's actually given you the colours here. So CuSO4 is white, and what does it turn to? Blue. So from white to blue. Seems really, really obvious. Again, sometimes there will be questions like that, so don't panic. Next one. Draw a ring around the meaning of the symbol. Endothermic, exothermic are involved. One would be exo and one would be endothermic, but the actual symbol means that it is reversible. Okay, so 1 mark for white to blue. 1 mark for reversible, with a total of 2 marks. So give yourself a total for this question. Now, if you are doing the foundation papers, so if you are in H3, 4, 5, and some students from H1 and 2 who after discussion with their teacher have decided to do the foundation, you guys are done now, so you can stop this video. Please send your marks, your total marks, to Miss Donaldson. Just put on their rates of reaction, and we will get that onto the spreadsheet. If, however, you are doing higher papers, so it's going to be the G's and some H1 and 2s, then you will need to stay for the next question. Right, so we're going to move on to question number 6, and there are elements in this question that is higher only, and I will point those out as we go through, but that's why only the higher students will be doing this one. Okay, so question 6. Bleach is a solution of sodium hypochlorite. So you've got sodium in there, chlorine and oxygen. Chlorine gas is produced when bleach reacts with hydrochloric acid, and it gives you the equation there. And hopefully you've picked up that this symbol is obviously reversible reaction. So first one, great link to the last chapter. Give the test and result for chlorine gas, and it's worth 2 marks. So I imagine most of you will have this. We need to have, the only thing that people are still slipping up on is that we must say damp or moist, either word, litmus paper. If you put blue litmus paper, great, but that is important as well. Okay, so we need to say damp litmus paper, and then the result is it's bleached, or goes white, either way. Okay, so that is going to be 1 mark, that is going to be the second mark. Okay, if you put bleach is damp litmus paper, that's 2 marks as well. Okay, right, so next one, the diagram below shows a sealed flask of sodium hypochlorite and hydrochloric acid at equilibrium. Remember, that means that the reaction is happening at the same rate. So the forwards and backwards are going at the same rate. So you've got a picture of it. Explain, so we must say why. Explain why equilibrium is reached in this reaction. Okay. Now, you may notice this. Okay, there is a lid or a bung on the top, which means that reactants or products cannot escape. So if you've said it's a closed system, they give you a mark for just saying closed system, that's fine. Or you can say no products or reactants can escape. Okay, so that's going to be your first mark. The second mark is something about the rates being equal. So no product reactants can escape. Forwards and backwards reactions are equal or the same, either way, for the second mark. Okay, so something about it reaches equilibrium because it's in a closed system, and that means the forwards and backwards reactions are happening at the same rate. Okay, and that's out of 2 marks. This would be higher. Next one, the stopper in the diagram above is removed and hydrochloric acid is added. The stopper is replaced. Explain what happens to the equilibrium. So we need to say what happens to the equilibrium, and we need to say why, and it is worth 4 marks. So we need to get 4 scientific points in there. Okay, so you must go back to the reaction. This is Le Chatelier's principles that you would have done on Wednesday. So if I'm adding more of this, okay, then it is going to want to sort of go back to equilibrium. So it's going to want to get rid of that. And the only way to get rid of that is to do that reaction. So there's going to be more of that forwards reaction. So what points can we say? Something really important, really useful to put is that it changes the equilibrium. So equilibrium shifts. That's the first thing. So adding more of a reactant, changing the temperature, changing the pressure, all of those will cause the equilibrium to shift. That's going to be worth a mark. Which way is it going? So you can say that it favours, or there's more of the forwards reaction. Okay, so it's going to do more of that reaction as opposed to that reaction. That's going to be another mark. So we're now at 2 marks. Why does this happen? So that's what we're going to be moving on to next. So why does that happen? It's because it wants to reduce the reactants, or you can say produce more products. Either way. Logically, to me, I would put to use up more reactants. It's going to be your 3rd mark. Until, so it keeps doing that until, you don't have to include until, so until a new equilibrium is reached. Okay, and that's going to be your 4th mark. So these two are saying what's going to happen, and these two are saying why. So the equilibrium will shift. It's going to favour the forwards reaction, so there's going to be more of the forwards reaction. Why is that? Because it wants to get rid of the reactants, okay? Because it wants to use up more reactants. And it'll keep doing that until there's a new equilibrium. That is definitely higher. Right, next one. Chlorine gas is also produced when hydrogen chloride decomposes. So we've got a hydrogen chloride gas, and it's decomposing to hydrogen and chlorine gas. The forwards reaction is endothermic. So my forwards arrow is endothermic. Predict the effects of increasing the temperature on the amount of chlorine gas. 2 marks. Explain your answer using Le Chatelier's principles. So we're going to get 1 mark to say what happens, 1 mark to say why. So that one is an endothermic reaction. So this way is going to get colder. I know this is a very basic way of talking about it. That way is going to make it get hotter. Okay, so if I increase the temperature, it's going to want to do the opposite. So if you're increasing the temperature, it's going to try and cool itself down. I know it's not a living thing, but think of it that way. It's going to want to go the other way. So it's going to favour this reaction. Okay, so it's asking what will happen to the amount of chlorine gas. So if it's favouring this way, it means that these will increase. So there will be more chlorine gas produced. Okay, so remember Le Chatelier's principles, it's all about doing the opposite. So if it's increased the temperature, it wants to get colder. If you decrease the temperature, it's going to try and get hotter. Okay, it's trying to go back to that balance, that equilibrium. So that's what's going to happen, and then we need to explain our answer using Le Chatelier's principles. So why does that happen? So there's a few answers that you can put. You can say that it does that or it shifts to counteract the change. They give you a mark. I'm just going to the mark scheme on that one, picking out the one that I would put. It says it shifts to take in energy. That's quite a good answer. Or you can say the system shifts in the endothermic reaction, so it's going to prefer or favour the endothermic reaction. So that's probably what I would have put. So it favours the endothermic reaction. So if you heat it up, it favours the endothermic. If you cool it down, it favours exothermic. So that's worth 2 marks. And that again is 100% higher. Right, last one then, 2 marks again. Explain. So we need to say why. Explain the effects of increasing the pressure on this equilibrium. So if you increase the pressure, the equilibrium, the reaction is going to want to decrease the pressure. So over here you have got 2 molecules, 2 hydrochloric acids. Over here you've got 1, here you've got 1, so you've got 2 on that side as well. So there's 2 molecules and 2 on that side. So what is going to happen, and don't be afraid to put this, there will be no change. Okay, because there's the same number of molecules on each side. Now that's probably from this paper was the first time it had a no change. All the others, they are expecting a change. But if you're looking at it logically, you're following the science, and you think that something's not going to happen, then that's your answer. Okay. Now, if it was a reaction, let's change the reaction. If it was a reaction where there was 1 molecule going in and 2 molecules coming out, if you increase the pressure, it wants to decrease the pressure. How do you decrease the pressure? Less molecules. So it's going to want to do more of that. So it would favour that backwards reaction, okay, to decrease the pressure. If I decrease the pressure of the reaction, it's going to want to do the forward reaction to make it go back again by making more molecules. Okay, so just remember with Le Chatelier's principles that it's all about going back to where it was. It doesn't like change. It will always try to go back. All right, that question was out of 12, so total that up. And if you have got any parts that you need to go away and revise, please do. Okay, don't just ignore it because it is hard. That's what's going to be in the higher papers. Right, thank you very much for joining me, guys. And I will talk to you next week. On EduLink will be the C2 paper that I've spoken about. Please make sure that you do that. It is really going to help you for when you return. So have a lovely weekend and see you next week. Very exciting. Goodbye.